Welcome to Section 4.1 AI Threats Overview. As artificial intelligence becomes deeply integrated into critical systems, it also attracts a growing range of threats. In this lesson, we'll highlight some of the most common and dangerous risks to AI models, from hallucinations to data poisoning, and place them within a structured defense framework. By the end, you'll have a clear understanding of why AI security requires prevention, detection, and mitigation working together. And now here are the objectives for this lesson. By the end, you'll be able to confidently identify common AI threats and attack types, understand risks posed by model misuse or manipulation, recognize high-level defense categories, and connect threats to real-world scenarios. So let's begin. What is hallucination? One of the most discussed risks is hallucination, where an AI system generates outputs that are confident but factually wrong. These responses can be persuasive, making them dangerous in high-stakes domains like medicine, finance, or law. For example, a system suggesting an incorrect medical dosage or inventing a non existent legal precedent can cause real harm. Hallucinations often result from incomplete training data or limitations in model reasoning. While some degree of error is inevitable, unchecked hallucinations erode user trust and can create cascading problems if decisions rely heavily on automated recommendations without human oversight. Data poisoning attacks target the foundation of AI, its training data. If attackers can insert malicious samples into the dataset, they can subtly bias or degrade the resulting model. For example, poisoning a spam filter dataset with mislabeled emails could allow attackers' messages to bypass detection. The danger lies in the stealth. Poisoned data often looks legitimate, and even a small fraction can alter model behavior significantly. Once trained, a poisoned model carries these vulnerabilities forward, making prevention and careful data governance critical. Strong validation, monitoring, and provenance tracking are essential countermeasures to reduce this risk. Prompt injection is a direct attack on how AI models interpret instructions. By carefully crafting a malicious input, attackers can override guardrails and cause the model to reveal sensitive information or perform unintended actions. For instance, a user might trick a chatbot into exposing hidden system prompts or confidential data. Prompt injection resembles SQL injection in traditional security. It manipulates the interface to force behavior outside intended bounds. Because many AI systems interact with untrusted inputs, whether from customers, employees, or the public, this type of attack is both practical and high impact. Defenses must anticipate and sanitize such interactions. Evasion attacks, also known as adversarial examples, occur at inference time. Attackers craft inputs with tiny modifications, often invisible to humans, that cause the model to make incorrect predictions. For instance, a slightly altered stop sign image may be misclassified by an autonomous vehicle, leading to safety risks. These examples reveal the fragility of AI decision boundaries and can undermine trust in applications like biometrics, surveillance, or fraud detection. Since the manipulations are subtle, they are difficult to defend against using traditional validation methods. Robust model training, adversarial testing, and layered defenses are key to reducing exposure. Model extraction attacks involve reverse engineering a deployed model by sending repeated queries and analyzing the responses. Over time, attackers can build a surrogate model that closely mimics the original, effectively stealing its intellectual property. This creates financial losses and also enables downstream attacks, since stolen models can be modified or probed without restriction. Extraction, extraction can also reveal sensitive information if the original model was trained on proprietary or private data. Because many AI systems are offered as APIs, this attack surface is growing. Defenses include monitoring query patterns, rate limiting, and watermarking to detect or discourage copying attempts. So, defenses against AI threats generally fall into three categories. Prevention aims to stop attacks before they occur through secure training pipelines, careful prompt filtering, and robust access controls. Detection involves monitoring the system for anomalies that suggest an attack is underway, such as sudden spikes in error rates or unusual query behavior. Mitigation acknowledges that no defense is perfect and focuses on reducing impact when breaches occur. This may involve fail-safe mechanisms, model rollbacks, or human review loops. A mature AI security posture requires a layered approach that integrates prevention, detection, and mitigation across the entire lifecycle of the system. All right, so to recap, AI introduces unique vulnerabilities that attackers can exploit. The five key threats: hallucinations, prompt injection, data poisoning, evasion attacks, and model extraction pose risks to trust, safety, and business value. Organizations must counter these with layered defenses against prevention, detection, and mitigation.